Hello everyone, welcome back to my channel Programming with a Purpose. This is the lesson 12 in the beginner series of learning iOS development using Swift. We are now moving to some of the advanced concepts in Swift. I'm going to discuss concurrency here. So basically you can see in the picture that there are three types of generally tasks. Sequentials are those that run one after the other. Then there are tasks that are known as concurrent, in which two or three subtasks basically interleave each other and run after each other. The third one is basically the actual parallelization, where two separate tasks run on two separate cores of a computer. So let's discuss about Swift, which has built-in support for writing asynchronous and parallel code in a structured way. Asynchronous code can be suspended and resumed later, although one piece of the code of program executes at a one point in time. Suspending and resuming code in your program let it continue to make progress on short-term operations like updating the UI, while continuing to work on long-running operations such as fetching data from the server or other writing data to disks and that sort of a task. Parallel code is basically the other type, where multiple codes run simultaneously. The additional scheduling flexibility from parallel and asynchronous code also comes with the cost of increased complexity. Swift lets you express your intent in a way that enables some compile time checking, like using actors, which I'm going to discuss towards the end of this lecture. Also note that if you have written concurrent code before, you might be aware of using threads. The concurrency model in Swift is built on the top of the threads, but you do not interact with them directly. An async function in Swift can give up the thread that it's running on. So when we are going to resume it, we may end up using another thread. So we are not basically sure which of the thread is working. So let's see what we can do with the code to enable concurrency in our program or our project. Here we are writing some of the helper functions that are going to finally write us some of the closures that can help us to download photos and display it in a stuff function show, which basically can involve any UI elements that is going to populate itself with an image. So basically this is the simplest way. If you want to wait for a certain task, instead of using an async task, you can write a completion handler, and then when you are calling it using a closure, you can basically wait for a certain task before moving forward. And although this is also a good solution, but it will require a lot of lines of code and can get quickly very complicated, usually with the use of nested closures. So here I am going to show you an example. Here I am calling a function list photos, and I am passing it a parameter, and this is basically going to be a closure in which photo names are generated and which are then sorted, and then we are going to get its name. These are simple steps, the step number 17 and 18. On 19 we are going to call another closure that is going to download that file, and it is going to then return, and on line number 20 we are going to display that image. So you can see that this is very simple task, but it contains 3 to 4 lines, and it can even get more complicated if it involves more closures. If you want to know more about closures, you can follow the previous tutorial that I have created on closures in this series. After that, we are updating the function list photos with a new definition that will involve an async keyword, and it is going to be an async function. So copy all of these lines and create an async function that list photos, and then download photos will also be an async function. Here it is going to generate an error. This is due to the reason that the type of result is not mentioned, so we need to make it as an array of string. We are going to define the type here, and we are going to comment out the code that is previously done. Here I am going to call the asynchronous functions that I have created with the keyword async. Here you can see that I have created a variable with the name of photo names, and we are going to use a keyword await. Wherever we are going to use async keyword inside a function, whenever we are going to call it, we are going to use keyword await. This is just like when we write a throws keyword in a function, we call it with a try keyword. So this is just like that. We have called a list photos function. After that, on line number 31 and 32, these are the two lines of code are sequential or synchronous. On line number 33, we are again going to call another function with the keyword await, which is going to be an async call. Here I am updating the basically signature and the definition of download photo function, which is again going to be an asynchronous function. So you can see that the suspension points are on line number 35 and line number 38. These are basically the suspension points. The code is going to stop here and wait for the result from these two functions, while it can perform any other tasks that is queued already, like copying a large number of files or passing data to the server, or to some other tasks that are pending will be completed. And when the results are returned, those tasks will be preempted and the code move back here and carry on the normal execution of the lines of code. So on line number 39, we are going to display that photo. It is here just a string, but that will be a UI image or any type of an image that we want to display. Now we are going to move to another code example, which is going to basically lay out another fact according to the async calls. So here we are creating a function with the name of add and remove. So it is going to do is basically it is just going to copy a file from one gallery to another gallery. But if we are going to add the two calls sequentially, like add and remove, you can see that there is a point in time where a file will exist both in one gallery and in the second gallery, and usually that may cause an issue if code breaks in between. So instead of adding suspension points, we can move it to another function move, and we can make both of these calls added to that function, and that will make it synchronous. So that will help us not to create an issue for this function in future. It will not generate a bug. And if we want to add concurrency, we can simply add it, and it will contain causes compile time errors and not basically a bug in the code. So this is how we can handle different issues of synchronous and asynchronous inside the functions that may or may not need to be created with async keyword or called with await. So here you can see that I'm calling that move function, and it is going to call the add and remove functionality in a synchronous fashion. After that, we are going to discuss asynchronous sequences. So for the previous function, list photos is going to return us a huge array of images in some cases. But if we do not want all of the input as a result, but we want to basically get one of the element of the input asynchronously and then start processing it to improve the basically throughput of our code, we can also do this. That using the line number 62, we can use the for await in loop, and here we are iterating over a file, each of the line of the file, and we are manipulating it. So it is going to make our code more robust. This is also a way in which you can use asynchronous sequences to improve the throughput of your code by using this for loop with await with each basically segment or each chunk of your input that can be returned from a function or from a handler in our case. So let's move towards parallel execution, which is basically the aim. We want basically the code to run in parallel so that we can leverage all of the resources of our system for our single app. So here you can see that I have created 3 lines of code that are going to download 3 photos, but we have used the keyword await. The problem with await is that it is going to wait for this result before moving on to the next line of code. So it means that although some parallel tasks can be played with it, but with these lines, these 3 photos will be downloaded sequentially, and then they are going to be displayed. So this means that this segment of the code is sequential, but it can be in parallel with another task or another code that is being run by the processor. Now we are going to make it exactly parallel like the actual parallelism, where we can download 3 photos and then we are going to display it. I'm going to show you that part of the code in a while. So here I'm going to write that code that is going to make it actually parallel. So I'm going to copy all of these 3 lines here, and you are going to see the syntax difference between these lines. So I'm going to remove the keyword await because it is going to create a suspension point, and these basically line of codes do not need to wait for each other. These 3 downloads can be done independently on separate threads. So here I have just added async let with each of the line, and on line number 80 we have set await. We need to basically wait for these 3 images before displaying. So await is a necessary keyword for line number 80, but for the above lines we need to remove it, and now this is the proper parallel code. So basically we can use a combination of await and async let to create a function to add special or necessary suspension points and ignore the rest of the code that can run as a parallel code. So this is basically the perfect form of the code that is required for this particular case, where we want to independently download all the images and then aggregate them and display it using our function. So here we are creating another thing which is basically handling the task and task groups. This is going to give us a finer control over the tasks that we are created. All of the child tasks that are created on line number 76 to 78 can be created using this code, and we can dynamically create as many child tasks as we want, and these are going to have one parent. So here we are going to iterate over the photo names that we have got on line number 84, and we are going to create a child task for each of it. This helps us to basically cancel or prioritize the tasks inside each of the group, and also you can see that we are able to create dynamically many number of tasks depending upon the count of the number of the photos. So this is an interesting aspect, and this is called synchronous concurrency. There is also asynchronous concurrency, which we are going to discuss next. So here you can see that we have done the code number 76 to 78 in a dynamic environment using tasks and task group. So next I am going to show you what is unstructured concurrency. Here you can create a single task. You do not need to define its parent, or you can define any parent according to your needs, and basically these tasks are created independently and you can do whatever you want to do with them. And afterwards I am going to show you the syntax how you can cancel a single task, so all of its correctness will be handled by the user in case you opt for the unstructured concurrency in your code. So here I have created a handle which is basically a task that is returning an await async function. After that it is going to get its value inside result, and this is how you are going to basically execute that task. And I have created an invalid redeclaration of handle, so I'm going to change its name both on line number 94 and line number 98, and now you can basically cancel it whenever you want depending upon your situation. So basically the syntax is task.cancel, basically the object of the task which is created like handle1.cancel, that is basically used to cancel this task if at any point you want to stop running this task. Now I'm going to discuss actors. Actors are basically the reference types that can help us to access the mutable state between threads that is basically sharing common data. So usually the concurrent processes do not interrupt each other and the data is usually independent, but in the cases where we want to share this data, we are going to initialize actors with a keyword actor. They are just like classes, and you are going to initialize them on line number 116 and 117 just like you initialize struct and classes. Here you can see that we have created a property with the name which is only updated using this actor object. So here you can see that when I am going to print the value, I am going to use the await statement, which is a suspension point, and that allows only one thread to enter into this actor at a single point in time. So here I have encountered an error while running it, so I'm going to basically comment out the previous code and then I'm going to show you the code here. And you can see that we are going to set the value which is set private to this actor temperature logger, and that is the max property. It is only going to be updated using this actor, and no other outside entity can update it. So here I am going to create an extension of this temperature logger. As you can see, with the function update, that is going to update the measurements, and then a maximum value is calculated. And you can see that clearly there can be a problem with this function, that if a task interrupts it in between and tries to read the max before the measurements are updated, a wrong max value can be picked. For that purpose, await logger.max is very important, so that the suspension point is created and no task is going to enter it before it is going to update all of its properties according to its method calls. So if we are going to call logger.max without await, it is going to give us an error. So it is going to protect us from reading the value that may be not in a proper state. Next, we are going to discuss sendable types, which are basically the custom types that are not that are mutable and can change its value while we are going to access them. So these types usually involve structs and classes. So if we have written already a type like this, a structure temperature reading, we need to add the keyword sendable, and it has a value measurement int, and we have created an extension to basically add reading to the measurements class, to the measurement object of our temperature logger class. So this is going to basically update the value, and we are going to await before getting any value after adding a reading. So as you can see that the value inside the temperature reading struct is not mutable, so we can basically, it is sendable by default, so we can remove the keyword sendable. But if we want to create a structure that is going to change, we need to basically add sendable. But if we have declared it already and we want to extend it, we can simply add sendable, just like the last line in the code where we have made the file descriptor sendable. So this is all for this tutorial. I hope you have learned something from it. It is a bit complex and takes some time to get absorbed. I hope it is going to be beneficial for you in future along with the other lessons in this series. Do not forget to subscribe to my channel and like and share these videos. Thanks for watching.